octagon is graphed below. Determine which of the following transformations would map the figure onto itself. So let all that apply. Okay. We talked about this yesterday. Whenever you're asked to determine what transformations will map a figure onto itself, essentially, what are we looking at? What did we talk about yesterday? What two things are we looking for when you're asked this type of problem? The order. What type of symmetry goes with the order? We talked about two types of symmetry yesterday. What two types? Look at your notes. They're right there. What type of symmetry did we talk about? Look through. Line symmetry. We talked about line symmetry. What other type of symmetry did we talk about? Rotational symmetry. That's what we're looking for. We're trying to figure out how to map a figure onto itself. We're looking for line symmetry and rotational symmetry. So go down the list of all your options. A says a rotation of 225 degrees about the center of the figure. That's rotation. We have to see, well, does that degree of rotation, is that going to map the figure onto itself? To do that, we have to figure out, well, what is my angle of rotation for this regular octagon? To figure out the angle of rotation, you remember from yesterday, you do 360 divided by the order. Right? If a figure is regular, we talked about this yesterday. A regular figure, what do we know about all the sides and the angles? They're the same. Right? And if all the sides and angles are the same, and there's 8 sides to an octagon, what's the order going to be? 8. When you have a regular figure, the order is the same as number of sides. Same thing with line symmetry. The number of lines of symmetry you draw is the same as the number of sides if it's a regular figure. Well, what's 360 divided by 8? What? You're right, but what is it? 45. Here's the thing. Can't we do more than one 45-degree rotation? Yeah, so we just have to see, well, does 45 divide into 225 evenly? And what is 225 divided by 45? What do we get? 5. We got a whole number. That means if we rotate that octagon 5 times at 45 degrees, it will be a total of 225 degrees. So yes, rotating that figure 225 degrees will work. 5 45-degree rotations equals 225. Let's take a look at B. When it's talking about reflecting over something, highlight that line. This is the x-axis. Then check and see. Is that a line of symmetry for that figure? Cutting that figure in half? We fold the figure over that line, is it going to map up onto itself? No. So is this going to be an answer? No. Lines of symmetry are lines of reflection. If you reflect a figure over its line of symmetry, it will map up onto itself. C's talking about an 80-degree rotation about the center of the figure. Well, does 45 go into 80 evenly? No. So that's not going to be an answer. Because if we rotate it 80 degrees, it will not map up onto itself. Okay, it has to be a 45-degree rotation. 45 does not go into 80 evenly. What about 270? Does 45 go into 270? Yeah, goes into 270 6 times. So if we rotate that octagon at 45 degrees 6 times, it will still map up onto itself. So that is an answer. 6 rotations of 45 degrees is a total of 270. E said E reflection over the line x equals 1. So I'm going to go to where x is 1. What kind of line are we going to draw through that? Vertical or horizontal? This is saying vertical. Draw through. Ask yourself, is that a line of symmetry for that figure? Yeah, so that's going to be an answer. Yeah, if we reflect the figure over it, one of its lines of symmetry, it will map up onto itself. And this last one says a reflection over the line y equals x. So we go to graph that line. I'm going to go to the center. The origin, just go up 1 over 1. And down 1 over 1. When we connect, is that a line of symmetry for the octagon? No. So that's not going to be an answer. It's not a line of symmetry. If we reflect over it, it's not going to map up onto itself. So those are your 3 correct answers. So if it is a rotation, you have to find the angle of rotation and divide into it. If you get a whole number, it's your answer. If you don't get a whole number, not an answer. If it's talking about reflecting, like those 3 did, you just draw in the line. If it's a line of symmetry, it's an answer. A line of symmetry, not an answer. Okay? Questions over that? Okay. Moving to the next page, we're now going to talk about symmetry of different types of quadrilaterals. Okay? And we're just going to briefly talk about, there's lots more about parallelograms, rectangles, and opposite squares, but we're just going to kind of briefly talk about their main definitions and what's special about them to help us understand the symmetry of these figures. So if you look at your shapes, this guy right here is a parallelogram. Okay? It's called a parallelogram because the opposite sides are parallel to each other. This side and this side will never touch. The top and bottom side are never ever going to touch. That's why it's called a parallelogram. Opposite sides are parallel. So down here, I'm going to mark that. I'm going to put arrows indicating that those sides are parallel. Okay? Another really important thing to know about a parallelogram, the opposite sides are the same. So those 2 are the same, and those 2 are the same. The angles are, all 4 angles are not the same. The ones across from each other are the same, but not all 4 of them are the same. So that's important as well. Just the opposite sides and opposite angles. But this and this angle are not the same. Also important. A rectangle, which is something you've heard before, it's also a parallelogram. So the opposite sides of a rectangle are also parallel. They're never going to touch. So you put arrows indicating that. Okay. But what makes it a rectangle is that all 4 angles are right angles. Meaning all 4 angles are the same. And just like a parallelogram, the opposite sides are also the same. So all 4 angles are the same. And opposite sides are the same. A rhombus, what makes a rhombus special, it's also a parallelogram, so opposite sides are not going to touch. But what makes it a rhombus is that all 4 sides are congruent. All 4 sides are the same. But just like a parallelogram, all 4 angles are not the same. And then a square, you've heard about a square. What's special about a square? What do we know about all 4 sides? They're the same. What do we know about all 4 angles? They're all the same. They're all what? They're all right. So parallelogram, not all 4 angles are the same. Opposite sides are congruent. Rectangle, all 4 angles are the same, and opposite sides are congruent. Rhombus, all 4 sides are the same, but not all the angles. And a square, all the sides and all the angles are the same. Just brief facts about about those to help you understand the symmetry of these shapes a little bit better. So now what we're going to do is we're going to determine if the following figures have line symmetry, and if so, we're going to draw them in. Right? So take a look first at your rectangles. This is where these are going to come into play. Start folding your rectangle different ways. Fold it across, up and down, diagonally. Fold your rectangle and try to figure out where are our lines of symmetry of a rectangle. And when you have one, raise your hand. Fold, fold. Chris, you have one of the lines of symmetry? You thought you raised your hand. No? Through the middle. Fold it hot dog style. Draw it through the middle. Fold it. They map up. Like this. Another line of symmetry. Okay? Yeah, fold it across like this. Hamburger style. Right? That's another line of symmetry. Are there any other lines of symmetry? What about diagonal? Can we fold it? If I fold that. Does that work out? Oh. Right? Those are the only two lines of symmetry for a rectangle. Because the sides next to each other are not the same. So when you try to fold it along the diagonal, that's what you get. They don't map up. You can't fold it diagonally. The reason why you can fold across both ways is because the opposite sides are the same and the angles are all the same. So the angles match up perfectly and the opposite sides match up perfectly. So for every single rectangle in the world, those are the only two lines of symmetry. Doesn't matter if you have a big rectangle or a little rectangle. Those are the only two lines of symmetry that you can ever make for a rectangle. Okay? Those two. What about a rhombus? Start folding your rhombus different ways. Fold it across, fold it diagonally. Try to see how you can get a line. And when you have a line of symmetry, fold it like, try to see if the sides match up. And see if the angles match up. How can we draw in our lines of symmetry? What do you mean by through the middle? So connecting one opposite vertex to the other, holding it this way, I agree. That worked out. I don't think I can turn this. No. So if you move your slant yours like this, okay, we folded across. These two are opposite of each other, and we fold it. So that one works, going from one corner to the other. Does it work for the other way as well? Yeah, if you fold it from this corner to the other, that works as well. But what about if you try to get the sides, if you fold it right down the middle of the sides? Does it match up? No, if you try to fold it this way, if you try to fold it through the middle of the sides that way, that's what we get. Okay? So those are the only two lines of symmetry. The reason why folding it down the middle of the sides doesn't work is because, yes, the sides are the same, but the angles aren't. So the angles don't match up because those angles aren't the same. So those are the only two lines of symmetry for a rhombus. And it doesn't matter how big the rhombus is. It doesn't matter how small the rhombus is. Those are the only two lines of symmetry from one corner to the next. I'm going to make an X to the corners. So now take your square. Start folding your square. Fold it down the middle of the sides. Fold it diagonally. See what our lines of symmetry are. When you fold it enough, it kind of folds and they match up. I'm going to show you what your lines of symmetry are. So when you have one, let me know. Brandon? Diagonal. Going across both ways. Folding it this way. Folding it that way. That works. Folding it diagonal. Both ways. Any other way? What? Yeah, all like right through the middle of this side, right through the middle of that side. All of them work. Because what did we say special about a square? What do we know about all the sides of a square? going to match up. All the sides and all the angles are the same. Questions over that? Again, a square, all the sides and angles are the same. It has 4 sides, so it's going to have 4 lines of symmetry. Next one, parallelogram. Start folding your parallelogram. Fold through the middle of the sides. See if you can get the opposite sides to match up. Try to fold diagonally. Try to get the opposite angles to match up. And when you have a line of symmetry, raise your hand. Fine. Play around with it. Did anyone find a line of symmetry for a parallelogram? No. Because parallelograms don't have line symmetry. You cannot fold a parallelogram any way for it to map up. They will never, ever, ever. A regular old parallelogram will never have line symmetry. Ever. Never, ever, ever have line symmetry. Because yes, the opposite sides are the same. But the angles aren't. So that's why they never map up. The reason why a rectangle works is because all the angles are the same and opposite sides. Right. The reason why a rhombus works is because all the sides are the same. So you have some sort of symmetry there. Parallelograms just have no symmetry. No way you can flip or fold a parallelogram for it to map up. So we'll never, ever, ever have line symmetry. Ever. Okay. Questions over that? Now we're going to talk about rotational symmetry with these figures. So get out your rectangle and see how many times you can rotate your rectangle a full circle that looks like the rectangle you started. To get back to the beginning, so rectangle right side up. How many times we rotate our rectangle? Start. Rotate it. Still not the same, 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 but there's one rotation that looks the same. Turn, flip, 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 back to the beginning, and it looks the same. How many times did we rotate it? Once, and then one more would make 2. We can rotate our rectangle 2 times. Start here. There we go, looks like the rectangle, there's 1. Go back to the beginning, there's 2. So it has an order of 2. We can only rotate a rectangle 2 times. Okay? To figure out the angle of rotation, what do we do? 360. Very good. 360 divided by the order. And what is 360 divided by 2? Oh my goodness. What's half of 360? 180. Thank you. So the angle of rotation for a rectangle is 180 degrees. Okay? For a rhombus, get out your rhombus. Where's my rhombus? How many times can we rotate the rhombus? How many times? To rotate it. Start. Here's the beginning. You can only rotate a rhombus 2 times. If I line it up here. Nope, 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 nope. There's 1. Nope, 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 nope. Back to the beginning, there's 2. So it only has an order of 2 as well. That means its angle of rotation is also going to be what? 180. Okay. We take a look at a square. You can rotate the square, but you can also use that helpful trick. We said all the sides and angles of the square are the same. And it has 4 sides. So its order is going to be what? 4. Okay, when it's all the sides and angles are the same, its order is 4. Yes, a rhombus has all the sides, it just can't go all the angles are. That's why it's different. So that means to figure out the angle of rotation, we just do 360 divided by 4. What is 360 divided by 4? 90. So the angle of rotation, so each rotation there's 90 degrees, 90 degrees, 90 degrees, 90 degrees. What about a parallelogram? 2 both ends as well. It doesn't have line symmetry, but parallelograms do have rotational symmetry. You can rotate it 2 times. Which means it's order. We are not done. We still have you for like a couple minutes. That means its angle of rotation is what? 180. That is true for every single parallelogram, for every single rhombus, and for every single rectangle. So when you see those words, you automatically know, oh, angle of rotation is 180. For a rhombus, a rectangle, and parallelogram. A square. All the sides and angles are the same. Have a good day. Start right early.